Welcome to lesson 4. In this lesson, I'm going to discuss RGB LED and how to interface RGB LED with Arduino. So what is RGB LED? RGB LED is a combination of red, green and blue LED. See this image? If I combine these three LEDs like red, green and blue, I'll get one LED with 6 pins. But I'm getting a RGB LED with 4 pins. How? Let me show you the circuit. Whenever we combine these three LEDs together, then there are two methods to combine them. The left side method is called common anode. Here the anode pins are short and connected to one pin. So there are three cathode terminals and one common. Total 4 pins. There is another way where you can short all the cathodes, and all the cathodes are short and connected to one pin, and there are three anodes. So there are three anodes, one cathode. That configuration is called common cathode. So both types of RGB LEDs are available in market. Whenever you want to purchase RGB LED, you should mention what you need: common anode RGB LED or common cathode RGB LED. Whenever you are using common cathode RGB LED, you should connect the common pin to ground and apply 5 volt at the anode terminals. But in case of common anode RGB LED, you should connect the common pin to 5 volt and apply 0 volt or ground at the cathode terminals. Then only these RGB LEDs will work. Let me show you how to test a common anode RGB LED and a common cathode RGB LED using multimeter. I have here one multimeter, one RGB LED. This is common anode. See, look at the LED. The long pin is the common pin. So I'll separate this and I'll connect the positive terminal of multimeter. See, when I'm touching the negative terminals at the LED cathodes, see, now I have switched it. LED is not glowing. But whenever I am connecting positive at common and touching the negative at the cathode terminals, the LEDs are clearly glowing. So this LED is common anode. Here I have one common cathode RGB LED. See, the longest pin here also the common pin. So I'll separate the common pin, and this is common cathode. So I'll touch the negative terminal of multimeter at the common pin, and now I'm applying the positive voltage at the LED's anode terminal. See, the LEDs are glowing red. If I switch the terminals, like applying the positive terminal at the cathode and touching the negative at anodes, LEDs are not glowing. But in this connection, the LEDs are clearly glowing. So this is a common cathode RGB LED. Here I'll show you how to test common anode RGB LED. The Arduino board, breadboard, RGB LED, resistance and wires I have. So let me put this common anode RGB LED on breadboard. I have marked the common. So I am connecting resistance at the other terminals. And at the common terminal, I am applying 5 volt. I am connecting it to 5 volt. Then I will power up the Arduino. Then connecting resistance at RGB LED. Remember, this is a common anode RGB LED. So what I will do, I am connecting this black wire to ground. Now let me power up the Arduino. If I touch ground at the resistor's end, see, the LEDs are glowing red, blue. In this method, we have to write our program accordingly. In this case, I have common cathode RGB LED and the same setup: Arduino board, breadboard, RGB LED, resistors and wires. So I'll put the common cathode RGB LED here, and I'll connect the resistances at the anode terminals, and I'll connect the common terminal to ground. But let me put the resistors first. So now connection is complete. Now I'll connect the common pin to ground. Here, if I apply a direct 5 volt at the resistors terminal, see the LED is glowing red. This is green. There are some loose contacts. See, green LED is glowing, and blue LED is glowing. So this is the method we have to incorporate in our code. Like for common cathode, we have to use digital write particular LED pin, then high. And for common anode, digital write that particular LED pin, comma, low. That way we can control the RGB LED. Now I'll perform an experiment with this common anode RGB LED. What I'll do is I'll switch on the red LED for 2 seconds, then green LED for 2 seconds, then blue LED for 2 seconds. And my methodology will be, I'll connect the RGB LED at some Arduino pins. I'll show you the circuit, and then I'll simply write digital write within bracket red comma low, then similarly green comma low, blue comma low. That will be my methodology. Let's see the circuit. So this is the circuit. If you see it clearly, I have used 220 ohm resistors for each of the terminals. The red is connected at Arduino pin number 2, green LED is connected at Arduino pin number 3, and blue LED is connected at Arduino pin number 4, and the common pin is connected to 5 volt. Now what I'll do, I'll program the LED accordingly, like digital write within bracket 2 comma low, 3 comma low, 4 comma low, like that I'll do the program. I'm not showing you the connections because this is very simple. I have made it multiple times and you have already seen it. So I'll directly show you the output. So let me write the code first. So this is my program. Let me define the LED pins. So int red at pin 2, then I'll write int green at pin 3. Similarly, int blue at pin 4. So inside void setup, I have to configure the pins. So I'll write pin mode red comma output, then green comma output, then blue comma output. This is a very simple program, like LED blinking. You can try this too if you have RGB LED with you. Sorry, I forgot to write output. My program is saved actually. So here inside loop, I'll write digital write red comma low, here I'll give a delay of 2 seconds. That was my objective. But here is a catch. Whenever I am writing red comma low, the green and blue should be high. That way, when red is low, green and blue is off. Red will glow. In any case, if green and red is simultaneously on or glow, then the color can be a different one. So see, low means on, so red is on, green, blue off, then delay 2000, like 2 seconds delay. Similarly, now I'll switch off red LED. That means I'll write red comma high. Then green comma low. Here I am switching on the green LED. Green comma low, and then blue comma high. Blue will also be off. Again delay of 2 seconds. Now at the last segment, I'll make red high, green high, but blue low. Blue is low. Again I'll put a delay of 2 seconds. Now my program is completed. Let me compile it. Then I'll upload the program. The program is getting uploaded into the Arduino. See, it's uploaded. Now if I zoom out, you'll see that in breadboard, the LEDs are glowing. Red, blue, then green. Red, blue, then green. I made a mistake. The 3 is not connected to green, 3 is connected to blue. That's why it's glowing in that order. If you have a stopwatch, you can measure that the LED is glowing for 2 seconds. Sorry, but to maintain a format, I'll discuss how to generate different colors using RGB LED in the next video. That will be RGB LED video part 2. One of the uses of RGB LED is it can generate multiple colors, whereas a single color LED can only glow to red or green or blue. But why RGB LED? We use RGB LED because through this we can generate multiple colors. How? Do you have any idea on color code? If you have, then you will understand it quickly. Otherwise, I'm telling you, there are color codes, RGB color codes we use while designing or printing. We use these color codes, RGB color codes. These color codes are of 8-bit, where you have to mention a value for red in 8-bit, a value for green in 8-bit, a value for blue in 8-bit. When you can combine these together in a single number, that number becomes the color code. See, I'm giving you an example. Suppose yellow. In yellow, the red should be 100%, the green should be 100%, but blue is not present inside that yellow color. So if you combine red and green together, then you will get yellow color. So if I mention the yellow color in ratio, then it becomes 255, that represents 100%. Then 255, it's also 100% for green, and 0 is 0 means blue. See, I have marked these in different colors. So whenever we design and in software like Paint, Photoshop, CorelDRAW, whatever software you use, you have to mention the color code, and color codes can be represented in these two ways. One way is writing RGB within bracket, you mention the ratio, comma separated format, in comma separated format, or use a hash, then mention the codes in hexadecimal, like 255 means FF in hex. So what will be the number? Hash FF00. This thing is known as the color code, and RGB within bracket 255 comma 255 comma 0 is the color ratio. So whenever you pick a color, it should have a color code. It can be represented in RGB color format. That color code we are going to use to program the RGB LED. How? We'll generate a duty cycle according to the ratio. Like when red is 255, that means 100% duty will be allocated to red. When green is 255, then 100% duty will be allocated to green. And when blue is 0, we'll allocate 0% duty. How we can generate duty? Using PWM signals, using simple analog write. So you have studied that when we write analog write within bracket a pin comma 255, it means we are giving 100% duty. So suppose I am giving you a ratio of 128, 0, 128. Then I am giving 128, that means 50% duty to red, 0% duty to green, and 50% duty to blue. How? Because if 255 represents 100%, then 128 represents 50%. That's how we got the color code, and that's how I'll program the RGB LED. Let me show you how we can program, but before that I'll show you the circuit. Then I'll make the connections. Then we'll write the program. Now I'll do an experiment with RGB LED, and my objective is to generate VIBGYOR spectrum. VIBGYOR means violet, indigo, blue, green, yellow, orange, red. I'll generate these 7 colors using this common anode RGB LED. And my circuit, as you know, that I have to use PWM signals. I have to generate rather PWM signals, and I have to use analog write function. So the pins should be capable to generate PWM signals. So that's why I have used pin 9, 10 and 11. 9 for red LED, 10 for green LED, and 11 for blue LED. See this circuit? And I'll be using analog write, and when I'll write the program, you'll understand in a better way. Common pin is connected to 5 volt. This will be my circuit. I think you have understood the connection. Let me make the connections. Here I have all the components: Arduino board, breadboard, RGB LED, resistances and wires. So let me put the RGB LED. I'll connect the common pin to 5 volt because I am using common anode RGB LED. I'll connect wires between the Arduino pin and the cathode terminals. So see, I have connected red at 9, now green at 10 and blue at 11. If you want to know the color code, then if you are using Windows, then open Paint. Then this is the Paint software. Go to Edit Colors, and here you can see red, green, blue. You can put the ratio here, like I am putting 255, then 255. See, this is the yellow color. So you can put any ratio of red, green, blue, any values in decimal. You'll get the colors of your choice. Like that, whatever ratio I'm using in my program, I'm going to use in my program. You can check those colors here by putting the ratio. So here I'm writing the code for VIBGYOR. So I'll define the pins first. So red is connected at pin 9. Green is connected at pin 10. And blue is connected at pin 11. Why I have taken these pins, I have already explained. So inside void setup, I'll simply configure the pins as output configured. Now here I am using a function called set color. Inside that, I'll put the ratio of RGB. So here I am giving a ratio of violet color, that represents V of VIBGYOR spectrum. Then I am giving a delay of a second so that the violet color is visible. You can visualize the violet color. Similarly, I'll write the color code, or you can say the color ratio of indigo. So this is the color ratio. This is for indigo. Here I have written the color code for blue, then green, then yellow, then orange, then red. Like that I'll do. So almost complete. Now the most important part, that is defining the function. Now I am writing the body of the function. The function is set color and it's a void type function. So let me write void set color within bracket. Now I am defining the variables int r, g and b. In this function, I'll write the main PWM function, that is analog write, because using analog write I'll be generating colors. So analog write red, comma, why I am writing 255 minus r, because I am using a common anode, because it is active low. So whenever I am writing low, the LED glows. That's why I'm inverting the ratio actually. 255 minus G. Similarly, analog write blue 255 minus B. This is the simple program. I have already saved the program. So now I have finished writing my program. So let me compile it, then I'll upload. Now the program is getting uploaded. See, the program is now uploaded to Arduino. Let me zoom out. I have used the cap of a PIR sensor, and now you can visualize in a better way. See the colors. You can let me switch off my light. See, the colors are now brighter, and you can visualize them in a better way. So this is my VIBGYOR program. I hope you liked it. In the next lesson, I'll discuss interrupts.